Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. We are going to look at mastering Pinecone indexes, interacting with Pinecone indexes inside Langchain, Demistified. Pinecone vector stores, a primer. Before we start about discussing about Pinecone, you must be aware of what is embedding, and you also need to understand why embedding is required. I hope that you guys have that particular information. If not, then I would suggest that please visit this particular playlist, and this playlist has the discussion on the embedding at the in this particular file. So if you take this particular video, I am discussing in detail about the embedding. So I am not going to discuss more in detail about it. We will be seeing the embeddings in action. Let us go back to the presentation. The point here is that I am using the openai.Embedding.create endpoint to just do a sample embedding creation, and we can see the embeddings using this particular function, this particular call to the res variable. I can get the embeddings, the actual vectors. Okay, so this is the first step. You have to create the embed. In parallel, you need to create Pinecone index. So in order to create Pinecone index, you need to go through this step. So you have to import Pinecone, you have to then create the Pinecone initialization, and then you have to create the index. You might be wondering, okay, why did I get this? Where did I get this dimension of 1536? So this comes from this area. I will be showing you all these things in Collab notebook. I'm just giving you an overall picture, not just with the steps, but I'm also giving you the code also, so that you will understand immediately what is going on. Once you create the index, usually here I am creating an empty index, right? You need to put something into the index. So you have to update the index, you have to insert, you have to upsert, etc. Okay, in this video I am not going to talk to you about upserting, updating, etc. Those aspects I am not going to discuss. Why? Because I am going to automate it using Langchain. The point here is that we can actually reload the index also. If I use pinecone.index, this Pinecone is actually the Pinecone libraries object. So you will see that a same object is used in Langchain also. So keep this in mind when you are seeing. So when I am saying that, okay, it is inside Langchain, then it is Langchain object Pinecone. And if it is inside Pinecone library, then it is Pinecone's own object. This is when we are actually jumping between multiple libraries, this is one of the challenges you have to keep track of and ensure that you are doing, you understand what you're doing. Then once you reload it, you can describe the index and see what is there inside that, and the interesting part starts here. So you can fetch based on the IDs. You can use the fetch method in reload that object, the Pinecone object, and you can get it back. Also, you can use the query option. So fetch is very rarely used. The most used option is query. So where you give the vector of the vector that you are trying to query. So what this happens is you will not, okay, here I have showed you a manual vector which is created by using list comprehension. In reality, we will not do this. So I will be showing that in the Collab notebook in a couple of minutes. So ensure, so all this model details, the functions, at this moment, don't worry about the top k and include values true or false, all those things. Just follow whatever the option is given. It works close to the required required output. Anyway, see, these things I am just introducing to you as a primer to Pinecone, but in reality we will be working mostly with Langchain, and most of these simple internal things are already abstracted away by the Langchain library. So in case of Langchain library, what happens is that you have to just use this method. So this Pinecone is, again, as I was telling, is the Langchain object and Langchain class, and from using that from existing method, I use the same test index that I created, and I can start working with Langchain object directly. So this is a primer. I am not directly take this data and take this code and try to execute in the Google Colab notebook and see what goes on. So that should be the way forward. Next, now we told that, okay, how to create the Pinecone index and how to interface with Langchain a bit. but in reality the flow goes like this. You first of all have to get the embeddings from the OpenAI using Langchain. This is purely from Langchain perspective. This is almost all of this is from the Langchain perspective only. So this you see that immediately here, right? I'm using Langchain's OpenAI embeddings class, and for making this to work, you have to have OpenAI API key. Ensure that it is already there in the environment variable. I will be showing that how to do it in the Collab notebook. Then I am going to use a test PDF, and we are going to load the PDF file using unstructured PDF loader. There is a reason for this. I will be telling that also. Unstructured PDF loader's load function effectively splits the PDF document also. You don't need to split it separately. Keep this in mind. Next, I am going to give an index name, and here you see that I am creating the index again. And in this case, I am actually creating the index, but I am not populating it. So I am still creating the index, but the population actually happens here. So I am going to create the Pinecone object, the Pinecone class I am going to use, and I am going to use from documents. So this documents is going to be this data file, which I got from unstructured library. So this data file will go into documents, the embeddings will come from here, and the index will come from here. So you see what is happening? OpenAI, unstructured library, Pinecone library, and all this is coming into Langchain library. So a lot of things are interacting together. This is why I am again and again telling, look at the problem. So whenever you are looking at something that you want to do, see what kinds of problems you have to solve. Most of the time the problems are already solved for you. Only thing is it's not solved as a single complete package. So you have to take solutions from multiple locations and use it together. So like the embeddings is coming from OpenAI, the file loading and splitting is coming from unstructured library, and then the index is the vector store is coming from Pinecone, and all this can be taken from online. So nothing is going to be from your library, from your own laptop. Then comes the actual hero, the Retrieval QA chain. The Retrieval QA chain is again from Langchain library, okay? But here what we are going to do is we are going to just change this test cone. So I have just given a name test cone, and you can use it as retriever. Once you make it as a retriever, then you can ask questions directly to it. Now you might be wondering, Kamal, you told me that we have to use the vectors here to query the Pinecone vector stores, but how is the retriever doing it? As I was telling you, Langchain does a lot of abstractions, and you might be, if you are really following it step by step, then I have to explain a lot of things. What happens in embedding? How is this retriever going to go and call the change the questions you give into vectors, and then use that vectors to find similarity inside the documents, and then retrieves the answer to you. That I can explain. However, it's not required for you. So at this moment, if you are trying to actually use these abstractions, use it as it is, okay, and you will get a very good result. But as you want to fine tune, once you get a base, minimum viable result, then you can start tweaking, start understanding more. So the most important aspect, what I find whenever I learn something, is that get the first result as soon as possible, and get it with minimum understanding. It's okay, get it with minimum understanding, but as you got the minimum viable result with minimum understanding, then you will slowly build up on that. So that is what I am aiming here, and I hope that I have given sufficient information to you guys. Also, in the next step, I will be also sharing you this entire notebook, and you can try it in the Google Colab environment. So the intention is, as usual, is for you guys to practice. So this Colab notebook, the test PDF also, the data also will be provided to you. Libraries are already available there. You don't need to, all you have to do is pip install. So I hope that you like this content, and leave a like, share it with others, and subscribe to my channel so that you will get further updates on Langchain and also big data related updates directly to your YouTube channel. With that said, let us go to the browser. So as I was telling, you can actually look through this. You can take a look at this particular discussion also. You will get more ideas on vector stores. I use ChromaDB in these cases. I have not used Pinecone, but you can still get the understanding what is going on. Let us go to the, okay, before I actually go to the, what is this called? I am not a robot. Before I go to this Collab notebook, I want to go here and check the Pinecone console. Just sign up for this console. You will get an empty index area. You will be allowed one index at one pod. They have a pretty restrictive setup right now. It's okay for testing and for understanding, it's fine, and you can also sign up for build option. This is empty index for me, and ensure that you have sufficient what is it called, tokens available for you to use it. We are going to use only embedding. Okay, so once you use embedding, the text embedding ADA 002 request will be sent. So I am going to use a very minimal file. So I'll be showing the file to you also. I'm going to use the minimal file, and if you come to this particular repo that I've been sharing with all the other videos, the same repo I'm using, and you will see the entire this Jupyter notebook here, and the data that I'm going to use will be inside the presentation. So I've kept it inside the presentation so that it is containing all the PDFs. So I've kept it inside the presentation. You can take a look at test PDF. So this is the PDF that we'll be working on. It's basically a Langchain. It's basically a Langchain user manual. I just converted it into PDF, so it will be easier, right? So anyway, you guys can take a look at that. With that said, let us go to the let us start working on the Collab notebook. So this particular cell is required inside Collab notebook, because sometimes when we do pip install of various libraries related to language model, the error on the encoding rises. So that's why I've running this. If you get it, then you can run it. So I've already installed Hugging Face, ChromaDB, and Sentence Transformer. I actually don't need ChromaDB, but I'm still installing it just for checking it in the future. And I have installed the config parser. These libraries I am installing because it is required for me, but you don't actually need to use it. So transformers, Hugging Face Hub, all these things can be used along with this notebook also if you want it. So let it be there, don't remove that. And these are the two hero and heroines of this particular notebook, OpenAI and Pinecone client. These guys we are going to work very closely. And PyPDF and Unstructured. So these are two different libraries that work with PDF files. So you will see what is the difference. I'll be showing you the difference also. This particular step where I am reading the this API data.config and test PDF. So I am reading this API data.config. If you want to look at how the file actually looks, the API data file, I have shared a example file inside the projects folder. I suppose it is inside the, just a minute guys, I think it is inside the Langchain exploration in yeah, this one. So this file actually looks like this. So I will have all my keys here with this particular names, and you can also add Pinecone key also. So add the Pinecone key at the bottom, and you don't need to put double quotes. So this is without the double quotes. Okay, so I hope that I have covered the basement of this particular topic, and let us execute this config parser. Let us get the, I am adding the OpenAI API key to the OS environment, and then I am importing the LLM. This is OpenAI LLM. I am making it as a fact LLM. Why I say this as fact? Because the randomness of this LLM is very, very low. I mean, it's literally 0. We are going to work with the documents, right? So we don't want it to hallucinate. Next is we are initializing the Pinecone environment. So I am using the API data to get the environment as well as the API key. So let me initialize that. And first and foremost, this is not required for you guys. You may not have any of your indexes, but if you have, then you can delete it using delete index. So once you init this Pinecone, you can work with Pinecone environment from Python. So that is how it is created. So you don't need to use GUI, and I don't like GUI. I love Python. So first we are going to create the test index. You might be wondering, okay, why are you giving 1536? I'll be showing it in a moment. Okay, let me create it. It's a straightforward activity. If you know basics of Python, we are just using the method of Pinecone object, and we are creating the test index. We are creating the index inside the Pinecone environment. So we will see it in a moment. You will see that, okay, if after I get the index, you will see a new index here. So right now there is no any index here, but once the activity is done, yeah, the activity is going to be done almost. So that will take a little amount of time, so be patient with it. And once the index is ready, you will see the test index here, and you will see the dimensions, you will see the rest of the info here at the bottom. And if you look at the index info, you will actually see nothing, but after some time you will see that the details start populating here. This is how you create the index. And if you use list index, these are all the basic methods that you need to be aware of inside the Pinecone for working with Langchain library. I am actually not going in detail about the Pinecone library here. I am actually going in detail about the necessary methods that is required for making Pinecone vector stores working with Langchain. Then we can describe the index using pinecone.describe index, so you will get all the details, the same thing that you get here. And then now we are starting the Langchain activity. So here I have started importing the Retrieval QA chain, and I am also importing the loaders. Two different loaders I am importing. I'll be showing you the example how it is different. Okay, so we will be using it. Then I am also importing OpenAI, and I am using the openai.Embedding.create. So this is not Langchain related. This is OpenAI related embedding.create endpoint. And here I am going to show you an example how the embedding works. So this is just an example. So I have already executed this. The sample document text goes here. This gets embedded, and also there will be several phrases in each batch. So these two sentences gets embedded, and you can actually take a look at the result. You will see that it is OpenAI object actually. And if you take the data result, so here it is telling that there are two parts to this data. So if I, for an example, if I take this out, so why to struggle? So if I use this, and if I say res.data, and if I take it will be a long list of it will be a dictionary. So let us see that, but it will be long, so don't get it will be pretty long. It's because 1536 numbers will be there. It's actually a dictionary. So if you want to get this embeddings, then you have to use the embeddings key here. So I am going to delete this, and here I am using the embedding key already, and inside the embedding key you know that there are 1536 vectors. So this is how embedding works, right? But we are not going to use this method at all. I am just showing you one of the ways where you can use this and then load it into the index. This you can do it manually, but we are not going to do that. I am just showing you what is the process. Again I am repeating that. Okay, fine. Now you can check the keys. There will be multiple keys here, and the most important key that you want to see is the usage key, because you will see how many prompts, how many tokens it has consumed. Okay, so this has consumed 13 tokens. It is not exactly same as the words. The tokens are a little different. Now, so that is about the embedding. Okay, let us go back to the presentation for a moment. I just want to get you guys give a comparison what is going on. So I have done this part, okay, and I have also done this part. I have shown you how to create the index, and I have shown you the basic activities of creating index. But now we need to look into these parts: index, getting the describe index, fetching index, and all the stuff. What we are going to do is I am going to hold this activity till we complete the loading of documents. Okay, so what I'm going to do is I'm going to load the documents, and then I'm going to use the embeddings and create embeddings, and then use the embeddings and create the index vector store also. After that I will show you these things. Okay, let us go back to the browser. Here there are two ways, as I was telling, right? So I am first loading using PyPDF. You have to install all these libraries or else it will not work. It will say that the library needs to be installed and it will stop. And you can either use load or load and split. Both actually do the same thing. This will split the file into two. You can actually add more splitting also, but I have not done any research on this, because Unstructured does a very good job. So this creates two documents, but I am using Unstructured PDF loader, and the mode should be elements. So all this information is available in Langchain document. I am not finding anything new. I am just using whatever is there in the Langchain document, and I am trying it out, and I am sharing it with you guys. So if I load it here, you will see the document loader gets loaded, and it also pulls in the NLTK library also. It does some various kinds of internal strategies, and then it splits the file. So if you look at this file, if you take a length of this document, it will be almost 53, I suppose. I forgot the number. Let me do the length of it. So yeah, 55. So it actually split into two, but this guy split this document into 55 chunks. Okay, so you can actually take a look at the document also. So let me actually show. Yeah, I will show the document later. Now the point here is that I have split the file. So the next step is I have to get the embedding. So I am getting the embeddings. The model will be text DaVinci ADA 002 here. That is the default model. If you want to check about what is the default model, etc., click inside the bracket and press Shift Tab. Okay, and give it some time, and you'll see that loading comes in. Okay, you will see such a activity coming, and then you can click on View Source. So this will give you the direct source of this particular class. You can read everything about that in the class directly. Okay. Now again I am deleting the index because I am going to create the index again. So I am using the test index as a constant. So you will see that this particular index will get deleted right now. I am going to delete it, and again I am going to recreate it. So why I am doing this again in the same video is that I want you guys to also understand by repetition. I want to tell you how is the index getting created. Deleting doesn't take a lot of time. Here the dimension, I know how it has come, I know how the index name came, and the metric is cosine, and then I'm going to execute. If the index is there already, what will happen is it will say the indexes already exist. So this is basic Python execution, so nothing new here. After creating the index will be empty. It's a database. Index is nothing. The Pinecone index is a new kind of a database where you store not just the numbers, vectors. You store the actual text also, but in a different format. We will see that in a moment, how to actually look at the format also by using the fetch command. So that is why I told you, right? Let us go back to the PDF. I told you that I will be discussing these steps after I load the document, because it will be much more useful. I mean, understandable for you guys to use it in your day-to-day activity. That is the reason why I deferred it. Let us go to the browser again. It is taking its own sweet time, because when you request for the new index, what happens is inside Pinecone console, it has to allocate inside the Google Cloud platform. They allocate a particular storage environment for you guys, and then they allocate the index inside that. So it takes considerable amount of time. So give it time, and it will get populated. So if this actually takes time, then hold for some time. I will be pausing for the video. As it is getting loaded, I also want to discuss about the vector stores. There are various different vector stores available here. The details regarding the Pinecone vector store, how to load it into the Langchain, I have got the details from here only. So this is how we load the documents by using this code. But here they don't talk about actually using the existing index. So how to use the existing index that is already created and available inside the Pinecone. So that also we'll see. So that is the one thing that is missing. So we'll see that how to use it here. So the index is ready right now, and we will see how to reload that index. Now what I'm going to do is I'm going to use this Pinecone. So this Pinecone is imported from Langchain vector stores. Okay, so this is what I was telling. So in the presentation that there will be multiple Pinecones. So this has a pine with a capital P, while that Pinecone that we are working on is all small letters, I mean lowercase letter. You see that, right? In case of the presentation, in order for the legibility, I had kept everything in uppercase. Okay, so that is only for presentation, not for actual use of code. So do not copy anything from there. Use only this particular GitHub document, this particular Jupyter notebook. So I'm going to execute this. This will actually now. So where is the Pinecone console? So let us go there. This index is already ready, right? And don't worry about what are these things, replicas, pods, etc. As you will, when you are going into production, yes, you have to understand all these things. And as I already explained, I am not primarily dealing with Pinecone here. I want to just talk about the interface that is happening between Pinecone and Langchain. And you see this ready. So once it is ready, you can start pushing the actual vector stores inside that. And once you see that the vector stores are already in, so click on this and you'll see the index info starts coming, and you see total vectors is 55. So now we know that the index has been populated. So we have 55, but we are not going to query from here. I will show you how to query, because the query has to be done through vector. You cannot directly query it like how we do it in other databases. So we need to provide vectors to query it. And this particular retrieval QA dot from chain type. So here what we are going to do is we are going to use the OpenAI LLM that we created at the top, and this test cone that we created. This is actually a Langchain object right now, and I can make it as a retriever. By using this method, I can make it as a retriever, and I am going to execute this test retriever. On this test retriever, I am going to say what are agents in, okay, let us change this. So let us say what are chains in Langchain. So once I execute this, you will see that it goes to the document and retrieves it. You can actually make it as a retrieval QA with sources. Chains in Langchains are prompts or utilities that assist in evaluation process. So this is what is actually there inside the documentation. You can take a look at that. Let me actually show it to you where I took it. So I went to the GitHub repo here, Langchain's GitHub repo, and if you come down here, this entire readme, I had copied it into the document and I have converted it into the PDF file. So this is what I had done. Okay, so the point here is that the initial discussion that whichever we are having is basically to get the data from the chain. So you have to also do fine tuning. So here you see chains go beyond just a single LLM call and our sequence of calls. This particular definition is not provided by the LLM. So this gives something totally different. Chains in Langchain are prompts or utilities that assist in evaluation process. So that has nothing to do with whatever is available here. So you have to understand that also. So whenever the reply comes from the LLM also, you need to also cross check it before you start using it. Okay, because you might have to start working on modifying the documents. So that one I will be taking it separately. I will be working on that also, how to modify the document so that we modify these splitting, because splitting is also important, right? And here what is exactly happening, so I will show it in a moment. So when we are actually using this chains, right, this particular so close. So basically let me take this, just a minute. So I am showing how actually what happens inside this run, because you guys have to understand that also. So I am taking this what are chains in Langchain and I am converting that into embedding by using this embedding endpoint, and you see the embeddings here, right? So this one cancel. So sorry. So I'm going to use that and I'm going to say test vector. Okay, and I'm going to attach it to, I'm taking that embedding and putting it in the text vector. Next, what I'm going to do is, I know that I already have this particular object. So what I can do is I can use this object and I can do a similarity search. That is one way. If I do a similarity search on this, let me show you that to you guys also, that we can do it in two ways. So if you are so if I use this and if I use similarity search, so you'll see that you will set the similarity search. So if I use the similarity search and if I directly give yeah, so I suppose sorry for the break. If you do the similarity search like this, and you'll see that, okay, so in my case what had happened is my environment got crashed. So since my environment got crashed, all my objects went away, but I have already copied all my vectors to, I have already loaded all my vectors to Pinecone database, right? So all I need to do is from existing index, I use this, I use the test index, I gave the embedding, this is required for the feedback, then I actually got my vector store back. So this vector store I can do a similarity search. So if I do a similarity search, what are chains in Langchain? So it will actually go into the document and it will find whichever part of the document is having chain, Langchain, etc., and it will return back as the complete series of list to us. And on this only, the where is this particular run executes. Okay, so if the similarity activity is not perfect, then we will not be able to get the perfect answer also. So I want to give you the background of what is going on. Next, I also told you that I will be showing you how to get the details from the Pinecone also. So there is that concept also, right? Instead of using capital P, we can use small p right now. So what I'm going to do is that I am going to say pine test index, okay, and I'm going to use Pinecone right now. And for actually reading from Pinecone, just a moment. So in order to make the Python environment to read the index, Pinecone index, all you need to do is use the Pinecone object and use index method and give the index name. And now if I say for this particular variable, if I use Pinecone index dot describe, so I will see that I can actually describe the stats. So I will get all the information regarding the details, how many vector count, what is the dimension, etc. And also I can do the search fetch also. So if I do Pinecone test index, okay, and if I do query, so I can actually do the query here. So there is a way to query. So in this query, when you are going to create it, you have to give the vector list. This vector list is what this is what I was talking about in the embedding. So this embedding, so in the query we need to give that embedding that we created using this particular test bed. We created the embedding and we got the vectors, right? We need to use that. If you want to get more details about that, you can actually go to the Python client inside the documents and you can take a look at query data. So if you take a look at the query data in this particular area, you will see that you need to give the vector code, you need to give the top pk. So you can just copy this, okay? Don't worry about that, just copy this and then come here and paste it. But instead of giving this vector, what you need to do is you have to give the vector that we have already got. So we got the test bed vector, right? The test vector. So take this test vector and provide the test vector here, okay, and then we are going to execute this. So once we execute that, what will happen is this will go and query based on the vectors. So you will see a lot of results coming out. So instead of actually giving it directly, right, I will say data from PC, okay. In this way it will get assigned to the variable, and then we can actually do the checking one by one. So that will be much more easier to manage, okay. And if we do a length checking on this, so we can check whether it is a list first of all. So I think it's not a list, so it's just a moment. If you take a look at the look at this particular variable, you will see it is a dictionary. So if I use the match, so this is the ID that we are talking about, right? So you can get this ID from here, okay. Take this ID, okay, keep this in mind, okay. Next, what we are going to do is we are going to use fetch. So we need the IDs actually. So what we are going to do is, first of all, let us take the matches. This is a process that I am doing it manually, okay, but all this is automated for you guys through the Retrieval QA. But since you guys have to understand it, I am doing it manually for showing it what is exactly happening, and it is more easier to do it this way. If we want to do it in the how to say, without actually looking at the object, right, it becomes very tedious. So don't try that option. Always look at the object, look at what is the object returning, and then use it. That way it will be more useful for you. So next, what I am going to do is I am going to use this ID to fetch. So I am going to use the data from PC and I am going to use the fetch method here, and inside the fetch method I need to give the ID. So the ID that I am going to give is this ID. So already I have got it here, so I am going to give that ID. And once I do that, what will happen is, okay, so we see that there is an error. Okay, so just a minute, I think that I am using something wrong here. I was using the wrong object, so I had to use the index. I was using the different object here altogether. That is why it was creating the problem. So I was using this. I was using the actual data that I had received already. So that is why it was showing wrong. So I had used the actual ID here on the index that I have loaded. And so this index, I have loaded it here. So if you go up here, you see this, I have loaded the index, right? So I had to use it on that only to fetch the vectors. So why I'm doing this, I will show you in a moment. The reason why I'm doing this, you see this. So once I use the ID, this ID came from, just let us go back. So this ID came from this test vector. This test vector came from, let us go up by using this query. So what are Langchains, right? So we use this, we got the test vector, and then we came here, we did the similarity search. This is not linked to that, forget this. We loaded the index from Pinecone, and then we used the vector search. So we used the query here by using the vector search, and we got a lot of matches, actually, not one match. So there will be multiple matches in this, and inside that one match we use the fetch, and this is how inside your Pinecone, this is how the data is stored. So there is the namespace, there is vectors, and inside the vectors there is ID that is linked. Okay, this ID and this ID is looking same, and then there is metadata. Metadata is what your document is, and then we have the vectors. So this particular document text has this vector. This is what I wanted to actually show you guys. So right now you have a very detailed understanding of what exactly goes between all these things. I mean, starting from embeddings, going to files, going to Pinecone Index, moving into the vector stores, and then actually working with it. So all of these things you understand from inside out. This is very, very important for you guys to actually develop on top of it. As you start developing more complex complex products, what will happen is these basic things will get, already you see there is a lots of abstraction, right? So you saw how the embeddings got totally abstracted away by the Retrieval QA as retriever chain. So everything got abstracted, and inside the Langchain library they have automated it. So you don't need to do any of the similarity check, you don't need to move the vectors between multiple locations. Langchain guys have done that for you. But you have to understand what Langchain guys have done, because in certain cases what will happen is you may not be able to understand these steps if you are looking it from the outside. So that is why I wanted to really show in detail what exactly is going on. I hope that you guys have a good understanding what is Pinecone and how it is linked with Langchain, and how we can interact with the Pinecone indexes. All these things, I hope that you really enjoyed this particular video. Do review it a couple of times, then you will understand more easily, and do practice a lot. Do subscribe to my video so that further Langchain updates I will be providing. I will be working on other kinds of embeddings also, like open source embeddings and open source LLMs also. At this moment I am targeting OpenAI because most of you guys are using OpenAI. So use that. At this moment, no issues. As the technology grows and other LLMs comes into picture, we will be having a very different way of the entire market. So till then guys, do subscribe for the channel, and stay tuned for the further videos. See you. And as usual, 4 words: practice, 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 practice.